So what I'll be doing in class is going over problems that are from the PowerPoint slides. So on the PowerPoint slides is where I'm discussing the topics, giving you the definitions, the reasons why we need to learn about significant figures, why and when we need to use significant figures. And then in class, what we're going to do is actually show you how to count them, how to use them in calculations, etc. So that's what I'll be doing here. So these rules that I have written off to the left are just the summary of the rules in the PowerPoint so that we can use them as reference and apply them when we're counting the significant figures in numbers. Okay, so there's going to be 2 videos every week, so whether you're virtual or in person, there's going to be a PowerPoint video, and then there's going to be problems on the board video. So always watch the PowerPoint before you watch the problems on the board video. Once in a while, especially for the Monday, Wednesday, Friday crew, because we only have 50 minutes versus the hour and 15 that Tuesday, Thursday has. So sometimes for the Monday, Wednesday, Friday crew, I might have more than one problems video. So if I don't get through everything in this 50 minutes, on Friday I'll post another one doing extra problems. Okay? So, let's go ahead and get started. Any questions? Starting off? If you can't find anything, always shoot me an email, or if the link's not working. We're no longer live streaming. People can't open the links half the time, and then with the internet connection here, it stops recording halfway through because I lose internet connection. So from now on, it's going to be YouTube videos. Everyone can open those, right? So I'll be converting these into YouTube videos and putting them up there. So let's start with significant figures. So whenever you are doing any calculations in this course, you need to keep track of what numbers are important and report it to the correct amount of significant figures. So that means don't give me extra numbers that don't matter, and then make sure you're including all the numbers that do matter. So to figure that out, we're going to use this set of rules here. The first rule is saying that the leftmost non-zero number is the most significant. Okay, that sounds a little confusing. All it means is the first non-zero number you see, that's where you're going to start counting. Okay, so in this first number, the first non-zero number I see is 1. That's where I start counting. Over here, 0, 0, those don't matter. I have to start counting when I get to my first non-zero, so I don't start counting till the 7 in this number. Okay, so that's what rule 1 is telling you. It's saying find your first non-zero number, going from left to right, and that's where you start counting. For number 2, any zeros between 2 non-zero numbers count. Okay, so basically, if the number is not 0, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, it counts all the time, no matter what. It's the zeros that are tricky, because zeros sometimes count and sometimes do not count. Okay, so number 2 is explaining the first stipulation, which is zeros can count, but if they are between 2 non-zero numbers. So an example would be this one here. We have a 0. How do we know if it counts? Well, rule 2 applies. This 0 is between a 4 and a 9. It's between 2 non-zero numbers, so this 0 will count as a significant figure. The last rule is giving us another time when zeros count. So zeros can count if there's a decimal and if you've already started counting. Okay, so let's look at this example here, negative 29.70. So we know the 2, the 9, and the 7 count, because we just said if it's not a 0, it matters. But we have a 0 after the 7, so to figure out if that counts, we're going to apply rule 3. It's saying the 0 can count if there's a decimal, and in this case there is, and if you've already started counting, which we have. We started counting at the 2, the first non-zero number. So this 0, yes, will matter. Let's apply it again up here. And I'm going to work through each of these and we'll count them using the rules. But to explain the rules, it helps to refer these numbers. So here, it's saying zeros count for number 3 if a decimal is present and if you've already started counting. So here I have 2 zeros and I have a decimal point. These zeros, these first 2 zeros, do not count. Why? There's a decimal point there. They don't count because we have to have already started counting. We cannot start counting till we get to our first non-zero number, in this case the 7. Okay, so we can't start counting until we get to the 7. So the zeros before, no matter if there's a decimal or not, they cannot count. Only the zeros after the decimal place, after we've started counting, can count. All right, so let's apply. Start off with the easy one. So I have 13.2. They are all non-zero numbers. So according to rule 1, they all count. So how many sig figs? Just count them. It's going to be 3. So the reason we're learning how to count sig figs this way first is because once we do calculations with them, addition, subtraction, multiplication, and division, we're going to need to count the sig figs to figure out how many significant figures need to be in our answer. All right, so the next one's a negative 29.70. So I wanted to put a negative number in here to show you that it doesn't matter if it's positive or negative. We're still counting the significant figures the same way. Right? We start counting at our first non-zero number, which is the 2. The 9 is then going to count because it's not 0. The 7 counts because it's not 0. So now we just need to figure out if that 0 counts. So we apply our rules. That 0, rule 2 does not apply because it's not between two non-zero numbers. But if we look at rule 3 says that zeros can count if there's a decimal, which there is, and if we started counting, which we did. We started counting at the 2, right? So that 0 does count because of the decimal and because we started counting. So now there's a total of 4 significant figures. All right, let's try the next one. You guys stop me if I go too fast. For people who are watching the video, they can pause it if I'm going too fast, so they don't need to stop me. So 530,000. Start counting at your first non-zero number, the 5. The 3 counts because it's also not a 0. Okay, well, do these zeros count? Rule 2 says zeros can count if they're between two non-zero numbers. Well, that doesn't apply, right? Otherwise, we need a non-zero number at the end. Rule 3 says zeros can count if there's a decimal point present. Can't talk. Is there a decimal point present? No, it's a comma. Comma's not a decimal. So since there's no decimal, these zeros do not count. So there's only 2 significant figures in this number. Okay, so here's our first example of zeros not counting. And they don't count because there's no decimal point and because the zeros are what we call trailing zeros. They're not between any two non-zero numbers. So I could add 5 more zeros there and it would still be 2 significant figures in that number. .09, we start counting at the 4. We know the 9 counts because it's not 0. So to figure out if this 0 counts, actually both of those rules say it does. This 0 counts because it is between two non-zero numbers, and also there's a decimal point present. So you can apply either rule, no matter which rule you choose, that 0 does matter. It is significant for a total of 3 significant figures. All right, let's go up to .0750. Now a minute ago we said that we can't start counting until we get to our first non-zero number. So we start counting at the 7. So that means the zeros before the 7 don't matter. It doesn't matter if there's a decimal point or not. They can't count because we don't start counting until we get to the first non-zero number. So the 7 matters, the 5 matters. Does this end 0 matter? Yes, it does. Why? Because of that decimal point. Okay, there's a decimal point and we started counting, so that 0 matters for a total of 3. How about 670? How many sig figs in that one? 2, yes. Okay, the 6 and the 7 matter because they're not zeros. That 0 does not count in this case. Why? No decimal. Okay, If we threw a decimal in at the end, it would matter. But since there is no decimal there, it's just those two that count. And we'll see that in the next example here. So in this case, for 1,000, the 1 counts, that's where we start counting. And this time, there is a decimal present at the end of the number. And the reason that decimal is there, because whoever wrote this number came up with this figure, whether it's a data point or whatever, they put it there to tell you those zeros matter, don't forget them. They are significant. So because of that decimal, all the zeros after that 1 are going to matter. So we have 1, 2, 3, 4 total significant figures in this number. Are there any questions on those few examples? Because what we're going to do next is we're going to be taking what we know about counting significant figures and we're going to apply it to doing actual calculations. Because in this course, there's a lot of math. You're going to have to add, subtract, multiply, divide, do math problems with word problems. And you need to be aware of how many significant figures are involved so you can report your answer correctly. So I'm going to write over here the rules for when we're adding and subtracting. The first thing you want to do when you're approaching a calculation problem is look at what order of operation you're applying. What I mean by that is, are you adding or subtracting, or are you multiplying or dividing? Because the rules I'm writing differ depending upon what order of operation that you're doing here. So, if you approach your problem and it says, okay, you're adding or subtracting, well, then you want to look at the decimal places only. So you're going to count how many decimal places are in all of the numbers that you're adding or subtracting, and then choose the least. So you always choose the smallest. Now, if you approach a problem and you're multiplying and dividing, it's a different set of rules. You're not looking at decimal places for multiplication and division. You're looking at sig figs as a whole, what we did here. So that's when the total significant figures are going to come in useful. The only thing they have in common is when you're doing this counting, whether it's decimal places or significant figures, you always pick the smallest and round to that. Okay, so it's always the smallest. So I'm going to write up a couple examples on the board, and we'll work through them. You can find where I put them. So. Their calculator here. I appreciate them, at least for some of the longer multiplication ones, multiplying it out for me. So I have to dig out my calculator and try to do board and that at the same time. Okay, so you'll notice if it's addition or subtraction, I lined up the numbers by the decimal point. Okay? I did this on purpose because when we're doing addition and subtraction, we're looking at decimal places. So usually when you're given an addition or subtraction problem, whether it's on a quiz or homework or anything like that, it's not going to be lined up for you. You might find it useful to write it on a piece of paper and line it up so you can see that decimal place position a little bit better. So let's go ahead and try the first one. So first thing you want to do is look at what order of operation are you applying. So in this first one here, we are adding. So we're going to count the decimal places. That's why I have it lined up. right? So you're ignoring significant figures as a whole, and you're just counting how many spots after the decimal are there in these two numbers. So in this first one, I have 3 decimal places. So I'm writing BP for decimal places. The next one, I have 2 decimal places. Okay, now I know that this first decimal place, it's a 0. It's not a significant figure, but that doesn't matter because for addition and subtraction, we're not looking at significant figures, we're looking at decimal places. And 0 is holding the 10th spot. It is a decimal place. So once you figure out how many decimal places for each of the numbers involved, you want to go ahead and pick the smallest, the least. So which number is smaller, 3 or 2? This is the easy part. 2 is always smaller than 3. So once you report your answer, you want to just go out 2 decimal places. This one I might be able to do on my own. 75. There we go. Please always correct me if I'm wrong. I calculated something wrong in my class just before this one. So it does happen, so please let me know. So this is the incorrect answer. I mean, on my calculator, that's what it shows me. It did the addition correctly, but I need to report it to the correct number of significant figures. And to do that, I need to go out only 2 decimal places, and this number goes out 3. Okay, so 2 decimal places, that means I want the 2, and I want the 7, and I want to stop there. But don't forget about rounding. Okay, wherever you're stopping, always look to the number next to where you're stopping and see, is that going to stay a 7, or do I need to round it up to an 8? And in this case, since it's a 5 or higher, you're going to round up. So it's going to be 3.28 is going to be the correct answer to the correct number of significant figures. So I only went out 2 decimal places, but how many total sig figs are in that number? 1, 2, 3. 3 sig figs. Okay, so be aware if you're asked a question, it gets kind of tricky where you're adding or subtracting, and I'll ask you, how many significant figures in the answer? Make sure you're calculating it out, counting the decimal places, and then getting your final answer, and then count the sig figs in your final answer. So a lot of people will be like, oh, 2. No, it's 2 decimal places, not 2 significant figures. You have to see what your final answer is going to be to figure out total sig figs. All right. The next one is subtraction. Nice. So it's going to be the same rules. Addition and subtraction have the same rules that apply. And the 0, 9, 9. Right. Yeah. Okay. Don't just say yeah. not. If you don't know, don't tell me. Okay. So 21.0999. That's incorrect, right? Because we haven't looked at decimal places yet. Since it's subtraction, we need to take into account the decimal places and choose the least. So this first number, 27.8, there's only 1 decimal place. The next number, 1, 2, 3, 4, there are 4 decimal places. Always pick the smallest. So I'm going to pick 1 because 1 is always smaller than 4. That means when I get down to whatever the calculator spits out, I want to go find the decimal place and just go 1 past it. So it's going to be 0.0. But just like in the above problem, check the number next to it. Does that stay a 0 or does it go up to a 1? And in this case, 5 or higher, right, a 9, it's going to go up. So my correct answer to the correct number of significant figures is going to be 21.1. All right, so the next problem is doing a multiplication. I cannot multiply that on my own, so will someone do that and tell me what they get on their calculator? So it's 12.307 times 0.03500. Ashley, right? So you don't remember.
It's 0.4307.
307, is there a number after? 4?
Thank you. 5.
And a 5?
Yep.
So a lot of numbers, okay? Obviously, we're not going to report all those numbers in our final answer. We need to figure out which ones are significant. So to do that, we're looking at what order of operation we're applying. Since we're applying multiplication this time, we're looking at the sig figs as a whole. So what we did a minute ago. We're going to count total sig figs and all the numbers involved and pick the smallest. So no more decimal places for multiplication. So looking at the numbers as a whole, the 1 and the 2 and the 3 count because they're all not zeros. Does this 0 count? Well, it counts for more than one reason. It counts because there's a decimal place and it's also between two non-zero numbers. So we have a total of 5 significant figures there. The next number, 0.03500, we don't start counting, remember, till we get to our first non-zero number, so that's going to be the 3. The 5 counts, and then the zeros after that are going to count because of the decimal point, and we already started counting. So we have a total of 1, 2, 3, 4 significant figures. So pick the smallest of the two. What's smaller, 4 or 5? 4. That's a bad marker. So we want to have only 4 significant figures in our answer. So we're going to start at our first non-zero number to start counting those 4. So we're starting at the 4. So that's 1, 2, 3, 4. So I'm going to stop at the 7. Look at the number next to it. In this case, is it going to stay a 7 or is it going to round up to an 8? Well, it has a 4 next to it, so stay the same. 0.4307. Actually, I think I remember the equation for this one. All right, so the next one's a multiplication again. When I multiply it out on my calculator, I believe it's 184. Yeah. But I need to check my significant figures and see, is that how I need to report it? So, order of operations, it's multiplication, just like the one above. So we're looking at sig figs as a whole. So the first number, 9.2, they're both non-zero, they both count for a total of 2 significant figures. Next number, well, we know the 2 counts, but do the 2 zeros count? So according to our rules, zeros can only count if they're 1 between 2 non-zero numbers, or if there's a decimal present. Is there a decimal? Yes, there is.
Okay.
Yeah, that's supposed to be a decimal. I know sometimes I write a little quick, I get a little sloppy. So that is a decimal, so that means these zeros count. We started counting at the 2, so those 2 zeros count for a total of 3. So to figure out how many sig figs our answer should have, we pick the smaller or the least. So 2 is less than 3. So we want 2 significant figures in our answer. So this is kind of a tricky one. So a lot of times people, they see, okay, I want 2 sig figs. So they're going to go 1, 2. All right, that's 18. But it's not. Because I can't go from 180 something down to 18. That's not the same number, right? That's not the same order of magnitude. So what I need to do is find a placeholder for this 4 that is not significant. So what's the only number I can put where this 4 is that's not going to count as a significant figure? 0. A 0. Zeros only count if there's a decimal point present, right? So as long as I don't put a decimal there, I still have 2 sig figs, and now I'm still in the correct range, right? I'm in the 100 and 80 range. So this would be the correct answer with the correct sig figs. So don't just stop and say, okay, it's 18. No, because you need to keep it in the correct range. So you can always add zeros if you need to without them being significant, as long as I don't add a decimal point to that. Right, one left. So 5 plus 4.81, that one I can add on my own. So I'm just going to write out the answer. Now, since we are adding, to figure out what we should actually report for our answer, we're going to look at decimal places. Addition and subtraction were decimal places. So this first one, does it have any decimal? It doesn't have a decimal. So it's going to be 0 decimal places. The next one, start at the decimal, and it has 2 numbers after the decimal, so it'll be 2 decimal places. Well, you still apply the same rules, pick the least. 0 is less than 1. So all that means is we're not going to have anything after the decimal when we report our answer. We're going to have a whole number. So in order to do that, you just look at all the numbers before the decimal point. In this case, there's only 1. Don't forget to look at the number next to it and see, does it stay a 9 or is it going to move up? In this case, 5 or higher, it's an 8. So it's going to round up to 10. So my answer is just going to be 10, no decimal place. There were 0 decimal places here, so we want 0 decimal places in our answer. All right, questions so far? No? Okay. So let's do scientific notation. And we're still going to be using our knowledge of significant figures in this next topic. So we still need to apply it. So if you haven't watched the PowerPoints yet, you might be thinking, what is scientific notation? So I'll give a brief overview of it. But for a more in-depth explanation, you'll want to check out PowerPoints. So I'm just going to write the rules for representing numbers in scientific notation so that we can apply them as we go. We have exponents. Okay, so what is scientific notation? It's raising to a power. It's the reason for this course you need a calculator with an EE button. All right, so I'll write an example. Usually, day to day, we write numbers in normal notation. 0.005, or if we write 1 million, we're going to add 6 zeros after it. So the nice thing about scientific notation is it's really helpful for really large numbers and really small numbers so that we don't have to add all those zeros and keep track of all those zeros that might not be significant. So for scientific notation, we're raising to a power. This is going to be the exponent. So it's always going to be times 10 to some sort of exponent. So I'm going to write a list of numbers in normal notation, how you see them on a daily basis. And we're going to represent them using this times 10 to the exponent. So we're going to represent them in scientific notation. And to do that, we're using the rules on the left side of the board there. So these are numbers, like you might see them or represent them on a daily basis. So to get them into scientific notation, we have a few rules to follow. So first, we want only one significant figure, and when I say significant figure, I'm talking non-zero number to the left of the decimal. Then, to figure out what the exponent's going to be, this guy up here, the magnitude of it, or the actual number itself, is going to be how many times you had to move the decimal to get it so that there's only one non-zero number to the left. Now, that exponent might be positive and it might be negative. So to figure that out, you're looking at the original normal notation. So for instance, if the original number is greater than 1, that exponent up here is going to be positive. Okay, so these two numbers here, they're both greater than 1. Right? 600,000, yes, that's much greater than 1. 1,500, much greater than 1. So I know just by looking at these, since those numbers are greater than 1, that I'm going to have a positive exponent. Right? If the number is less than 1, so this guy up here, it's 0.0 something. If it's less than 1, your exponent, once you have it in scientific notation, is going to be negative. Okay, so that's how we figure that out. And then last but not least, check your sig figs. So let's try these out and see what we get for our scientific notation representation. Now, since significant figures need to be kept, before I start moving decimal points around and muddying up what the normal notation looks like, I'm going to count my sig figs first. Because once I start moving my decimal points around, I might not, it's going to be harder for me to tell what numbers were originally significant. So, just count sig figs like we were doing a moment ago. So you start counting at your first number. So we're going to start counting at the 1. The 8 also counts. And in this case, since there's a decimal, the zeros that come after we already started counting do count. So we have a total of 3. So I'm writing that here so that once I represent it in scientific, I need to double check and make sure I still have those 3 significant figures. So now, let's start getting it in scientific notation. I'm going to start with rule 1. So I'm going to put a new decimal point here. I'm going to move this guy. And I'm going to put it so that there's only one non-zero number to the left of the decimal. And there's only one spot I can put it to achieve that. And that's going to be between the 1 and the 8. So if I put it between the 1 and the 8, I have just one number to the left. That's what rule 1 is saying. So this is where my new decimal place is going to be when I write this in scientific. So I'm going to write the first part. Notice I kept that 0 so that I still have 1, 2, 3 significant figures. If you leave that 0 off, you have the incorrect number of sig figs and the answer is wrong. Okay? So I have my new decimal point. I know since it's scientific notation that I'm going to be writing times 10 to the something. So my next step is to figure out what is that exponent going to be. And number 2 tells me. It says your exponent, the number that you're going to put there, is how many times you moved that original decimal point to where it now lies. So my original decimal point is between these 2 zeros. I want to get it so that it's between the 1 and the 8. So to get it there, I'm moving my decimal 1, 2 times. So that means my exponent's going to be a 2. But now you need to double check and see, does it stay positive? Is it supposed to be a positive 2 or a negative 2? And that's where this is helpful. It's saying that it should stay a positive exponent if your original normal notation number was greater than 1. If your original number was less than 1, it should be negative. Our original number, it was less than 1. So we want to make sure we're adding a negative in front of that. Now, some people prefer, when they're trying to figure out whether it's positive or negative, instead of remembering, okay, that number was less than 1, so it should be negative, they look at which direction they had to move the decimal. And you'll see that in the PowerPoints as well. So if you move the decimal point to the right, it's going to be a negative exponent. If you move the decimal point to the left, it's going to be a positive exponent. So that's another way to remember it. So choose which one sticks in your head and keep that. All right, try another one. So the next one, let's do our significant figures first before we start moving decimal points around. So all non-zero numbers matter. Are these zeros going to matter this time? No, there's no decimal point, right? And that's the nice thing about scientific notation. We can lop those zeros off. We don't have to rewrite them again. So there's only 3 significant figures in this number. So when we report it over here, we should just have 3. So to get it in scientific notation, remember we want to put our new decimal point so that there's only one non-zero number to the left. So which 2 numbers should it go between? 6 and the 7, yes. So I'm going to write that over here now that I know where my new decimal should be. So 6.73, that's 3 sig figs. I'm forgetting about the zeros. Times 10 to the, so what will my exponent be? Well, we said it started the decimal. How many times do you have to move that decimal to get it to where you put your new one? Well, this number doesn't have a decimal point in it originally. So where do you think we should start? If you don't see a decimal in the original number, it's always at the end of the number. Okay, so we're going to start here. So to get it between the 6 and the 7, I'm going to have to move that decimal 1, 2, 3, 4, 5 times. So my exponent is going to be a 5. Now in this case, I'm keeping it a positive 5 because I moved to the left and the original number was much greater than 1. All right, let's count sig figs for the next one. I know the 1 and the 5 count. Do the zeros count in this case? Yes, I put a decimal point there to make them count, right? So this time the zeros do count. I have 4 sig figs, and when I write it in scientific notation, I need to make sure I keep all 4. So I'm going to put my new decimal point in scientific notation is going to go between the 1 and the 5 so that I have one non-zero number to the left. Making sure that I keep the zeros so that I still have 4 significant figures. Remember, significant figures are just the numbers present before this multiplication sign. To figure out the value of my exponent, I'm starting at the original decimal point and seeing how many times I have to move it to get it between the 1 and the 5. And in this case, it's 3 times. It's staying a positive because I moved to the left and because the original number was greater than 1. Questions? So we're going to do the reverse. I'm going to give some scientific notation ones and we'll figure how to write them in normal. And that covers pretty much all you need to know to take the first homework quiz. And to go on the discussion board too. Don't forget about posting on the discussion board. Whether you have questions on this or you found some extra homework problems that you found useful that you used as practice problems, anything like that. Share it with your fellow classmates. So these are all all scientific notation because we have 10 raised to a power in each one. So we're going to take these now and essentially reverse these rules to get it back into normal notation and see what that looks like. So notice all of these numbers have one non-zero number to the left of the decimal. That's what they should have. That's the first rule of scientific notation. So to figure out how to get them in normal notation, we're going to get all our information from the exponent. It's going to tell us how many times to move that decimal point to get it into normal notation, and whether it's positive or negative will tell us what direction to move it. Right? So if it's a negative exponent, you want the number to get smaller, so you're going to be moving the decimal to the left. Because negative means the original number was less than 1, so you want to make it smaller and go to the left. If the number is positive, the exponent is positive, that means the original number was greater than 1. So you want this number to get bigger, and to do that you have to move the decimal to the right. Okay, so positive exponent, move the decimal to the right. Negative exponent, move the decimal to the left. So let's apply. Starting at the decimal, to get this in normal notation, I'm going to move that decimal point twice. Since it's negative, I'm going to make the number smaller, and I'm going to move it twice to the left. So here's where my new decimal point is going to go. What do you think goes in that empty space? A 0, correct. So normal notation will be 0.078. Is that correct? Even with this, check your sig figs. So one thing I didn't do before I started moving decimal points around was count my significant figures, right? So let me go back and do that to make sure that I kept the correct amount of sig figs. So my original number, have a decimal point, right? So this 7 counts, that 8 counts. We know they count because they're not zeros. But does this 0 count?
Yes.
It does count. There was a decimal point, right? So there are 3 significant figures in the scientific notation form. How many significant figures do I have here?
2.
I just have 2. This 0 doesn't count because I can't start counting until I get to my first non-zero number. So I need to add a 0, exactly. So it's good to always double check your sig figs. If I add a 0, now I have 3 significant figures just like I had here. All right. So before I start moving the decimal point around again, let me count my sig figs on this one. This one's pretty easy just because they're both not zeros, so they both count. So there's 2. Just make sure you still have 2 once you have it in normal notation. So now I'm going to start at my decimal point, and I'm going to move that decimal 5 times. Which way, right or left?
Right.
Right, I want to make the number bigger. It's a positive exponent, so I want that number to get bigger. So I move it once, it's on the other side of the 2. Move it 2 times, 3 times, 4 times, 5 times. So here's where my new decimal point is going to go. So that means after the 2, I need to put zeros in each of these places. So I'm going to have 1, 2, 3, 4 zeros. So writing it over here, I'm going to have the 5 and the 2, and I just said I need to add 4 zeros. So it's going to be 520,000. Make sure, I know I moved the decimal point and put it there when I was trying to figure out how many zeros to add, but you do not want to keep the decimal point there. Because if I keep it there, I've now changed it from 2 significant figures to 6. Because by having the decimal there, I'm saying those zeros count. And they don't. They shouldn't. So make sure you don't keep the decimal in that one. All right. 3 minutes left, but we only have 2 problems, so we're going to push through. Especially since this one's a tricky one. All right, so let's count sig figs quickly. How many? 5. All of them matter because of that decimal point. So I'm going to move this decimal point how many times? 3. We're looking at the exponent. It's a positive 3, so I'm going to move it to the right to make the number bigger. So it's now going to be between these 2 zeros. So over here, I'm gonna get 1900. Is that correct?
Point
0.0.
zero.
I need to add the decimal and that last 0 so that I still have 5 significant figures. Yes, good. Last one's a trick question.
3.0.
It's just 3.0. Okay, so whenever you're raising to the power of 0, well, the exponent tells us how many times to move the decimal point. And this is telling us you move the decimal point 0 times. So if you move the decimal point 0 times, it's the same number. So it's just 3.0. Excuse me. All right, so we've covered everything that we need to this chapter. Scientific method is the only thing I didn't talk about in class because that is concept problems, and so you'll find that on the PowerPoints. I'll probably post a video with some scientific method examples anyway on Friday in lieu of class, so that you can see more examples than are just on the PowerPoints. So if you have any troubles viewing the PowerPoints or anything else, let me know so that I can get that fixed. The